Welcome to Clark Classroom. Don't forget to subscribe. This is another example where the application of vectors is appropriate. A 2,000 pound weight is suspended by two cables, AC and BC, at 50 degrees and 30 degrees to the horizontal, as shown on the left. Determine the tension in each cable supporting the load. This system is in equilibrium, and that means there must be equal and opposite forces that maintains the system in equilibrium. Therefore, the vertical components of the tensions in the cables are supporting the load. And since the system is in equilibrium, the vertical components must be equal to the load. It follows also that the horizontal components of the tensions must be equal to each other. Let T1 equals the tension in AC and T2 equals the tension in BC. Then if we resolve T1 into its horizontal and vertical components, then the horizontal component will be T1 times the cosine of 50 degrees, and the vertical component will be T1 times the sine of 50 degrees. And resolving T2 also in its horizontal and vertical components, then we have T2 sine 30 to be equal to the vertical component and T2 cos 30 degrees to be equal to the horizontal component. That sets up for us these equations. So the vertical components T1 sine 50 plus T2 sine 30 degrees must be equal to the load, which is 2,000 pounds. And similarly, the horizontal components, that is balancing out each other, that's T1 cos 50 degrees, must be equal to T2 times the cosine of 30 degrees. We need two equations, since there are two variables, in order to solve for T1 and T2. Now, finding the trigonometric values and substituting them back into these equations, we obtain 0.766 T1 plus 0.5 T2 equal 2,000, and 0.6428 times T1 is equal to 0.866 T2. From this, express T1 to be equal to 0.866 divided by 0.6428 times T2. And from that, we obtained T1 as 1.3473 times T2. And now we substitute what we have for T1 back into equation 1. And so we have 0.766 times the value for T1 being substituted there, plus 0.5 T2 is equal to 2,000. Continuing with the arithmetic, we have here 1.032 times T2 plus 0.5 times T2 equal to 2,000. So now we have eliminated T1 from this equation, and now we can solve for T2 by dividing both sides of the equation by 1.532. We obtain 1,305.48 pounds for the value of T2. And now, to find T1, we simply take the value for T2 and substitute it in this equation right here. Substituting the value for T2 there gives us T1 to be equal to 1,758.88 pounds. And that concludes our solution for this problem. If you find this video useful, please subscribe to this channel, and I welcome your comments and or suggestions.